Hello, welcome to the second part of the set of the videos, the tutorials dedicated for integrating large language models on generative AI in web services. So in the previous video, we stopped at the system that are capable to generate the streaming output in the form of the data, as you can see in the test scenario. This is the predefinite data. Well, in this approach, we're going to make step forward to replacing it with the data that's obtained from the third-party providers like OpenAI, Replicate, and any other that hosts large language models. And to approach this is what brings me to the diagram that we previously reviewed and how specifically we can extend it in this video. So in the previous video, we stopped at implementation of the proxy server with JSON chunks. And in this video, what we're going to cover is that we use the additional library written in Python that represents non-string approach for attaching extra adapters for these specific services that allows you to get an access to the large language models that they are hosting. With all of that, I'm referring to the system that we're going to use to extend our the implemented code for the tutorial. And that particularly brings me to the app, which is called the bulk chain. So what is bulk chain? I just give you a quick introduction, followed by the integration in our demo. This is the system that presents a no-string approach for using third-party services, such as OpenAI, Replicate, and any other platforms that host large language models. The installation is relatively in usage, relatively straightforward. So what we have to do is just using the one method in which we have to submit the prompts that we would like to use, initialize the service, followed by the passing data and iterate the content that being passed inside. And to access it, we're going to use another service, which is the third gate. This is what brings me to the concept of adapters that we just overview on the diagram. And we're going to use the replicate provider to access the related models, which is particular would be a series of the Llama 3 models. Okay, well, without further ado, this brings me to the console, where we continue the previously implemented project. I'm in the folder which is Streaming Web Demo, which just contains the GS Fast API as the folder in which we implement the content from the previous video. So we're going to start by just copying everything and modifying it for the tutorial in this video. So I'm going to copy it with the new folder that I'm going to call bulk chain. And once we are in this folder, what we're going to see is that from the previous video, we have set up for the GS to support streaming. First of all, let's modify and have a look on the content in this file. It's worth to say that previously it contained, and from the very first part of the previous video, streaming of the predefinite data from third-party service. So this is no longer need for that. So we can only keep the content of the stream iterator in this case. Next, and the most important file is LLM stream. So what we see here is that we previously have the predefinite set of the chunks that we are sending. This is where we kick in and integrating the bulk chain or no string framework for supporting the third-party adapters. So how we're going to approach this is first we're going to add the dependencies for the bulk chain as a project. Next, we have to initialize the large language model, which is in particular going to use the replicate adapter, which is going to put this code in this file and later on continue to provide necessary files in the project directory. And then is what we finally see from the description page for the project is that the code which is related to the stream answer is no longer supposed to provide us the predefinite chunks, but instead we have to provide the content based on the question that we provided as an input prompt. I'm starting to put this step by step. So first of all, as data, we're going to use your data iterator, which is based on the question. It's just a single prompt that involves the question. We're setting up the data iterator content, again following by the description provided for the blockchain project. And finally, we're gonna iterate through this content by retrieving the chunks and sending these chunks as an output. All right, once we set it up with this file, it's worth to say that there are predefinite parameters that's also supposed to be provided in order to being possible to launch it. One of them is the API token. In this context, we're using the replicate platform, and to do so, you have to go on your specific account. However, for this video, I prepared the temporary token, which is brings me here, and I have to copy the content. Okay, and last thing is that we, as you can see here, since we do this initialization based on this replicate 104 version provider, it inevitably means that we have to create the related file in our directory. Okay, so this is in order to proceed with this. Let's continue by creating this file. And as for the content, we have to borrow it from the third gate providers, and particularly by using text and the code written into this file, which is LLM directory replicate 104. Perfect. So we set up we set up the provider to the replicate. Last thing before launching the new server is that, and for the demo that we initially see in the beginning of the video, we have to link it with the scripts that's related to this approach. So in the main section of this folder, we have the demo page, and it has the connections with the script files. In this particular example, I already changed. However, initially it was only provided initially it's provided only the reference to an LLM stream post. So I have to change it to the bulk chain folder that we created for this video. And I guess we're nearly there. So all we have to do, and since we at the moment launching this script that we see by the beginning, we have to stop the related server. So this is what's been launched in another tab in the terminal shell. I'm going to stop it, and by going to we're going to launch the server. Okay, so it says that the intent doesn't match the outer intention level. So this is happening because of apparently wrongly copied the content of the stream.py. Okay, so now indentation has been fixed. So, and once we continue with this, in order to launch in the server, we can see that it is necessary to install addition in the library, which is the bulk chain, which brings me back to the page of the project. And we have the particular script that allows us to install it from the latest version from the GitHub. We're going to copy this, but in this particular context, I'm using the locally installed pip3. Okay, and we also have to install the replicate. Okay, finally we launched the server, and let's come back to our initial form. that is still supposed to work, but now is connected to our different server. And then we attempted to ask what's the color of the sky. So as we send the submit, we see that the response is processing at the moment, and as a result, we can see set of the chunks. This is something that could be also modified in this video. I believe this is the misimplementation that we saw into the initial HTML web page, and this particularly brings me to the section of the processed stream data, where, and as you can see for the code, all we do is when we receive the content, we just add the content as it is to our result string, which represents the chunks of the data. To replace this, I already prepared the code that is supposed to copy, but the concept is pretty straightforward. So all we have to do is just, instead of stacking the chunks that we collect, extract the data parameter, which represents the actual content and the text that's supposed to be displayed on the HTML page. So once the page is saved, all we have to do is just refresh the content and resubmit again. And then this time we're supposed to see the proper text in the output. And as a good catch, what you can also notice within this implementation, if we try to submit the query again, we can notice that there is no sign of streaming, although the output represents the fully data obtained from the LLM that is streamed from the Fast API side. And to be honest, it took me a while to just investigate the problem, and this goes beyond the scope of the initial aspects of the video. However, it's worth to also cover for your awareness on why and if the related problem is happening, so you cope with this. So this again brings me back to our project folder, and the problem originates from the HTML page and the content that we have for this demo, which is index generated HTML. All we have to do is just navigate to the handle stream part, which is, and according to the implementation, as you can see, it pretends to collect all the data first and then return the result. So the updated version is supposed to look as follows. And within this implementation, all we changed is that when we handle the content, we automatically add it to the output box, so we no longer see the issue of long awaitance for the full response completion before rendering the result. So once it is there, all we have to do is just come back to this form, update the page, and resubmit the query again. Now, as you can see, we have a full complete setup that are ready to go. With all the further updates and customizations, you can closely adapt your demo project that might support the bolded text or any other annotations that again goes out of the scope of this video. And without more further ado, this was the second part of the videos for the LM integration into the web environment. So thank you very much for watching, and see you in the next one.